Hi, it's tubalcain again. Welcome back to the shop, and this is part 3 of the Casting Specialties drill press vise build. So where I'm at this point, of course, if you've watched the other 2 parts, I've got the jaw machined and fastened, and in the last episode I made the screw. Oh, and one observation on that, I talked about using that Banggood half center. This is the number 3 size. I also got one in the number 2. It's carbide tipped. And that's what I use. Remember the purpose of that. It just gives so much clearance here for your cutting tool. But they sure did a rough job there. And the other thing is, when I went to get this out of the tailstock of the closing, it wouldn't eject. This wasn't quite long enough, so I think I'll tap that and put a screw in like several people have done. And you say, well, that's too hard. No, it's not. It's softer than spreadable margarine, so I will drill and tap that. That's sometime, not today. Today's emphasis and project is really the hardest part, and that's where I'm going to drill and tap the hole. Now, I've already located that hole, and even center punch. It doesn't show up real well, not at all for that matter, in the casting here, but that's ready to go. And I also tentatively marked it there just so I can see about where it's going to enter the movable jaw. Not that I have any control over that now, because remember, that's going to all be drilled at one time. But while preparing for that and thinking about it, I was looking at this little Stanley Yankee vise, probably 80 or more years old, and it's pretty beat up, but it's one of my favorites. It's so cute and so well proportioned. It's 2 inches, Acme thread, round knobs here, but taking a look at how it's constructed is really nothing like the more modern vices, and it's very complicated here, the way they've got that assembled and engineered with a slot. That's really something. See if you can see that with a flashlight. Must have been rather difficult to make, and then 2 tiny little set screws here holding that in place. Furthermore, in all modern vices, all the vices I've seen, such as this Palmgren, the screw is held in there with a dog point set screw in a little groove, and you know, that's always kind of shaky, but that's how I'm going to do mine. But look at how they made this. There's some kind of insert in there, and I'm not going to take it apart, but holy mackerel, is that complicated. Furthermore, this had replaceable jaws. One, however, is missing, might have been missing for 60 years, who knows. But that's a nice vise. Alright, back to the business at hand. I like to do the drilling and the tapping on the Bridgeport mill. It certainly could be done on a drill press, but it's just more risky in terms of how many errors that you can make. Now, to put it in a vise like this is a bit outrageous, because it's raised it up about 3 inches already, and it's hard to get all the room that you need up here for your drills and your taps, and just all of the different tools that you're going to use. So I'm going to use an angle plate. Also, this could be done on a horizontal mill, and in fact we did at the high school put them on a horizontal mill in this manner. And then, of course, the spindle and the tooling was here. That's a wonderful method, because you got a good view of it, and it's just an easy way to work. But of course, I don't have a horizontal mill, so I'm going to do it here. But I'm going to take the vise off and clean up the machine now. All right, now get a load of this set up, and there's got to be 101 ways to do this, but this is my way. This is an angle plate here. It's about 5 inches by 5 inches. I already have it bolted here with T-bolts on the back, squared up real nice. Now, the reason I've got this in this position here over this T-slot here is that this flange here will fit down in there and drop it down really about another inch. So using 7/16 hex bolts here, and it's the first time I've used a 7/16 hex bolt, I think, since I went through puberty. But I'm going to put a washer and a nut on this side and snug it up nicely. and yet another bolt up higher, and that will have to be removed later on when I drill through the, when I drill into the movable jaw, and then I want the jaw out of the way when I tap it. So then I'll remove one of the bolts and drop that, and then re-bolt that so that it's good and tight and it can't swing on me. I want it to be vertical. If this hole is not drilled and tapped perfectly vertically and straight, all is for naught, and it's nothing but a bunch of scrap iron. Now either use a precision square such as this to square it up. I like to use another angle plate just temporarily. Push it up against the angle plate, and then I'll tighten down the two bolts. And you know, I just got this wrench out. It's 11/16 wrench that fits those nuts. I always wondered what an 11/16 wrench was for. I have 50 of them and never used one. Alright, I'm satisfied now that it's perfectly square this way, and I know that it's square this way. And I double checked it because maybe that was a bad angle plate. I haven't used it. And I like these slotted angle plates. Now, as I mentioned before, I want to drill all the way through the main casting here and into this casting, the movable jaw. That way I know that it's going to line up rather than going by dimensions or a drawing. So I need that held up there as I do the drilling firmly. So that needs to be clamped, but then I will take the clamp off and I can drop that out of the way and tap just this piece without the tap going into this. So do you understand why I'm doing that? And I'm going to use another vise to help make a vise. So I'll put the palm grin on there, which seems to fit in there a little better than trying to use an awkward C-clamp, but I'll probably grab another C-clamp and pinch it over here so it's up underneath here. These were very difficult concepts to explain to a 16-year-old. So I really had to do some tight supervision when they did their drilling. Now I got to drop the table way down because I have to do a lot of tool changes. I like to lay my tools out because there's really only one shot at this, but I'll start by locating the work under the spindle with the wiggler, and then there's a center drill or a starter drill, 1/4 inch bit already marked to the depth with a Sharpie, the 27/64, which is the tap drill size, and here's a tapered 1/2 13 tap, hand tap, and I'm going to hand tap it. I'm not going to power tap it, but it could be done. Here we go with the wiggler. Okay, I'm right on, and what I do now is to lock the table in both axes, and I zero out the digital readout so that if I have to move everything aside for a tool change, I can relocate it easily enough. And the center drill. Do you ever catch yourself trying to blow away the chips on your computer screen? And here's the 1/4 inch. Nice chip formation with cast iron. And I just felt it break through, and now I'm drilling into the jaw. And you see the mark on the drill bit? That seems kind of crude. You could set a stop also for that. Right there. And now the tap drill size, 27/64, are just a little bit of a wobble. Now I'm ready to tap, so I need to drop the jaw down. You know, I like using this clamp because it's extra strong. Now the jaw out of the way, and I'll install a tap follower. And I'm ready to tap. And there we go. And off it comes and over to the bench. It's looking good, but next I need to determine where to cut off the screw. It's too long, and then the end of it has to be turned down to 27/64, which, if you look at the end of this, that's what it's going to look like on threaded around here. So there's still going to be some thread showing, but it won't hurt anything because I'm going to make a groove in there. So notice that on this vise there's a few threads left, so that's about what I want. And that might take most of the center hole out of there, which is fine. Actually, when I look at it this way, this will go into the jaw about that far, so I can take off. It could be left the way it is, but I'd like to get rid of at least some of that center hole. I was going to hold the screw in a collet so there would be no damage to the thread, but I think this will be fine. I've already faced off about 1/4 inch off the end of it and turned it down to 422 thousandths to a length such that the jaw fits right on nicely, 27/64. And I wanted the bottom of this hole to be flat because this is flat. All the pressure should be exerted by the end of the screw when you tighten it. So I wanted that to be flat, so there's a regular 27/64, and there's my bottoming. So I flattened out the bottom with the bottoming drill. Next thing I need to do is drill and tap a 1/4 20 thread there for my dog point set screw. And I'm going to do that first so that I can again transfer or locate it through this hole and onto this. So the location is exactly correct. And I'll be using a dog point screw. Alright, I've drilled and tapped a 1/4 20 hole for the set screw. And I spent about 15 minutes again looking for a dog point set screw. Now this is what a dog point set screw looks like. A little large, don't you agree? But you know, one time I went to a box store and I asked the clerk for a dog point set screw, and well, I'm not sure whether it was a man or a woman waiting on me, still not sure, but he or she took me to the pet department and showed me dog collars. So anyway, here's one, but it's got a brass point. This might do, or at least it'll do for the setup here, and then later on I'm going to cut it off and put just a little bit of a slot in there, and it'll be a slotted screw. That'll have to do till I get back to the box store. Okay, now bringing the screw up as far as it'll go, I'm going to take a 13/64 transfer punch, and I hope this shows up because you know there's a little bit of a trace of a thread in there, but we'll see. Now I'll take it out and we'll have a gander at it. I center punched it in a couple spots. They show up really quite well. The whole idea now is I need to make a groove there using a cutoff tool, and it needs to be, it fits into the 1/8 inch, just a little wider than an 1/8 of an inch, and about that deep, whatever that is, maybe less than an 1/8 of an inch, 3/32. And the whole purpose of that is to allow you to withdraw the jaw. It has no effect on tightening. If something was bound up too tight, pulling it out, in the case of this brass one, it probably would break the brass off, but I would like to replace that with a steel one if and when I come across one. So I'll go over to the lathe now and make that groove off camera. Well, you know what I did? Instead of using this one and complaining about it, I just took a few minutes and made my own dog point set screw just by holding my Dremel tool, holding this in the chuck and hand holding the Dremel tool. Only took a couple minutes. Anyway, now you don't want to force this down. Just comes in contact like that. Now it needs to be Loctited upon final assembly because they do tend to work their way out. The rotation of the screw sometimes causes a little twisting, so I will at some point put a dab of you-know-what on there. Alright, that's quite enough for today. What I'm going to do tomorrow and get a fresh start is close this all the way up and mill the side off, the top and this side, just enough to clean it, because remember, this has never been machined, nor has this part. And then make a handle for this, and then the job is done. So I'll see you on the morrow. Howdy again, and welcome back. It's another day, and I'm refreshed and ready to go here. And before I start with the project, and there's about 15 minutes left of video, perhaps 2 hours to finish this, but I was just looking at my email, and a man by the name of Ken sent me an interesting quote, and he said, "A man who can fix nothing is at everyone's mercy." And isn't that the truth? So one of the last things I'm going to do here is I've got 1.5 inch parallels here, and I'm going to put it in there and machine just the top off here just to clean it up. No dimensions given there, but I can't squeeze it by the vise right here because the jaw is thicker than the body, so I need to get it somewhere below the jaw. So I've got 1.5 inch parallels in the vise, and we'll tighten it up like that, and using the 3/4 carbide mill, just run right across there. I've also tightened the vise here so that they're squeezed together and be milled as one. Here we go. Next, I'm ready to mill the sides. Now, it's not going to set flat, again, because of that jaw, so I do have some real thin parallels sitting in here. You can't see them, that will set right here where it says tubalcain, so it's going to set on that. Oh, let me say something here. Be careful when you handle a cast iron piece like this. If I were to grip this in let's say, the bench vise for some kind of operation or layout, it could be squeezed and cracked. Cast iron is very brittle, so that'll be laid in there like that, and I need to have some way to clamp this rather than on here, because this is not the same height. So I prepared these aluminum packings here, and one will be setting like that. You won't be able to see that, and this one on the top, and that's what will push against it and hold the bottom of the vise up against the fixed jaw. And I milled this piece down such that it is a little bit lower than the vise. Matter of fact, I wasted at least 15 minutes preparing those packings. And you can see that I'm not squeezing that or this. All of it is in the middle, and I'm using this 2-fluted carbide mill. 2 carbide inserts, I guess I should say. And I'll take one more light finishing pass off camera. And one more slow feed finishing pass, and then I'm done. I'll do that off camera. It's looking good. Of course, that could be surface ground because there's always going to be some tooling marks, but then again, look at the tooling marks in this palm gun from many years ago. So this vise has apparently been ground. Anyway, a couple spots here that didn't clean up, but I wanted to keep this vise as large and thick as possible. So, you know, to take that out of there would mean taking off about another 10 thousandths. I didn't want to do that, and I don't find that all that objectionable. See how black one's hands get when working with cast iron? Now the next step, I'll take my file and just break all the corners a little bit. There really isn't any burr, but any of these corners that were affected by the previous operations I'm going to knock off and break, and then we'll talk about the handle. Now let's talk about handles, and there's countless ways to do this, and in the high school shop we made really thousands of C-clamps, gear pullers, vices, and so on over the years, and the way that we made the handles normally. And remember, some of these were metal shop projects, not machine shop projects, where the boys weren't using lathes, but we would take 1/4-inch rod, thread it, put a nut on it, tighten it down real well, and then grind it off round. Now in the machine shop, get on there. On the machine shop, in the machine shop, we could use the lathe, and that would clean up pretty nice. Sometimes we started with a bolt, and that already had a head there, but and it could be faced off. But what happened is the kids would take this onto the grinder and grind them. Well, if they're holding it on a grind wheel like this, it's going to spin off, and bang, you could hear them fly across the shop. So I would tell them to hold it this way, but of course, and that would be self-tightening, but you know, that wasn't really going to happen. So looking at some of these, here's one that's been cold-headed. And the advantage of this, of course, is that you can install it and then tighten it up, or use Loctite. I don't think we used Loctite back then, but that's been cold-headed. Here's one, this Palmgren, that I believe were press-fitted. Not real sure, but that looks like the way it's done. This little one, I really like the looks of that. It's got balls on it, and like they went to the extra effort. Take a look at C-clamps and vices around your shop, and you'll see all different varieties of that. But I decided I like this, and this is how I'm going to do it. That's just a sample I made up. So that's a 7/16 ball, and I got a couple of those, but of course they are hardened ball bearings. That's about the right proportional size for 1/4-inch rod. And what I'm going to do here, what did I do with it? I lose things that quickly. There's 1/4-inch rod, 3-inch long, and that's drill rod. I'm using drill rod because it doesn't have a tendency to bend so much if somebody forces it, but the ends have been chamfered, and that's all prepared and ready to receive the balls. So let me show you how I'm going to do that. Annealing is a simple operation. You've seen me do it, so all I have to do is heat the balls up until they're red hot. That's the critical temperature, about 1600 degrees. It isn't very critical at all as long as I hold it there for a minute and then let it cool very slowly. I'll demonstrate to you how it loses its magnetism when it is red hot. Of course, that returns as soon as it starts to cool. So I'll just use the propane torch. You know, I went to use this now, and that canister was totally empty. And I've got this is Ace brand here. It leaks. I don't care how tight you make that. You come back a week later and that baby's empty. But I do love these self-igniting ones. There's something kind of exciting about them. And these are setting on little nuts. That's just a little altar for them while I sacrifice them. The balls are already at the blue stage, which means they're at about 600 degrees. Now the blueness will disappear here momentarily. They'll turn back silver as... Now I could heat them up much faster with oxyacetylene, but this is what I've got. You use what you've got. Now that's the critical temperature. What I like to do then is take the flame away, and as it cools, just keep hitting it a little bit so that it cools over a period of about 5 minutes. And I won't show that because it's too tedious. I'll see you when both balls are soft. Okay, here's one of the soft balls. Look at that, how nicely that files. So what I'm going to do is put this in a 3-jaw chuck on the lathe, and using this stubby starter drill, which I have already pre-marked at about, well, this is 7/16, so that's 3/8 in. I don't want to drill all the way through. And ultimately, I'm going to use Loctite to hold that on. So over to the lathe I go. Can you see the little ball in the jaws of the vise? Now the jaws have these grooves in it, so it's seated in a groove and it cannot get pushed back. It's almost like a stop. I had to put these in the lathe and file them down just a little bit. I wanted enough clearance so that there would be some Loctite in there. Make sure you assemble this before you Loctite it. And I've been using lately Loctite 638, which I got from KBC. You don't need much of it. This is green. Usually I use a red Loctite. Okay, and I rather like the black color. I don't intend to polish that. Nice little contrast, but don't those look nice? Don't you think so? A little extra work and a trip to the hardware store to get yourself some 7/16 balls. You know, almost all of the box stores even have a selection of balls. I noticed they got brass ones too, so at the sacrifice of the monkey. Alright, I'll be back after I eat lunch to finalize this, but I'm about done. One final thing could be done to the vise. I don't think I'm going to do it, but notice that a lot of vices come with V slots here for round work, horizontal one and a vertical one. It would be pretty easy to put the horizontal one on without using extra jaws. You see, this has steel jaws on it. I'm not going to do that, but in order to put a V in there, and I laid one out, let's go over to the mill and I'll show you how I would do that if I was so inclined to actually make the cut. Back at the Bridgeport, I set the vise up at a 45-degree angle using a gauge such as that, or it could be a combination square head, and then looking down here at the layout that I made a few moments ago, just with a regular end mill of virtually any size, a person could go ahead and mill that V-slot in. Alright, the vise is done and it operates smoothly and just nice. I need to put a couple drops of oil on there. Now, admittedly, no one in all of Christendom will ever make one of these. That was probably the last set of raw castings left on this green earth made by Casting Specialties, but I think from watching a 3-part video like this, you can see the many different operations that I did that could be adapted to what your project is. And I also understand some people are just watching this for the pure entertainment value of it. And you know, I'm wondering sometimes if any women watch this. So if you're a woman, just leave a comment saying, "I am woman, hear me roar." Or anyone from Croatia watching, leave a comment. Or anybody else that wants to, for that matter. I hope you enjoy the video, and I got a heck of a job here to clean up the shop after doing this 3-day, 3-part video. So thank you very much for watching. Continue to watch. I have a lot of videos out there, and I hope to see you in my next video. This is tubalcain saying so long for now.